In this second tutorial, I'm going to show you how to measure and compare the accuracy of different forecasting techniques. So in our tutorial number 1, I was showing you how to run 4 different time series on a simple dataset. So we have the results. Now, of course, we would like to know which one of those methods was the best one. And for that, we need to have some kind of measure of accuracy. And there are 3 ways we can measure accuracy in forecasting. The first method is called the MAD, mean average deviation. And it simply takes the absolute value, or the distance, if you like, between the actual demand and the forecast. Second method is called the mean squared error. The mean squared error is very similar to the MAD. The difference is that we square that distance and average it. The last method is called the mean average percentage error, and this one expresses the MAD, if you like, the average deviation as a percentage of the actual demand. What I did is I pre-formatted my Excel spreadsheet here to make it easier for you, and what I did is that the Excel spreadsheet here is programmed already to compute the average scores that I'm going to input here. So let's do first the MAD. And because we want to compare apples to apples, we're going to start comparing the performance of those 5 different techniques only on time period number 4, because before time period number 4 I don't have data for some of those techniques. So we'll start at period number 4. So for the naive, I'm computing the absolute value of the actual demand minus the forecast. And because I want to save time, I'm going to add the $sign in front of the B here. Enter. That's my distance. I drag it down here, and that gives me the deviation for the naive technique. And if I want it for all of the other different technique, all I have to do now is to drag it to the right. The scores here are the average deviation that are computed automatically because I had prepared the spreadsheet before. And the score highlighted in green here is the lowest of the score, meaning it is the best of the method. So for my example here, and using the MAD as a way to measure accuracy, I can tell that the best method is the weighted average with an average deviation of 2.41. Let's do the mean squared error now. The mean squared error is similar, except that we're going to take the square of that distance. So it's really the same score of the MAD, but squared. So equals this time this. So the same thing. It's just squaring that score. Drag it down, take it to the right. So according to this method, what I find is that the technique that gives me the most accurate result is the exponential smoothing with a 0.3 weight. Let's do MAPE now. MAPE is simply the absolute distance between the demand and the forecast, and I divide by the actual demand. And that's expressed as a percentage. What this number says essentially is that my forecast was 7.5% away from the actual demand. Again, I need to make sure that I have the $sign placed in front of the B here. I'll take it down. That's for the naive, and then I drag it all the way And what I find here is that MAP agrees with the MAD in a sense that it's telling me that the best method is the weighted average with an average error of 5.85%.